Okay, let's start the meeting. Good morning.
Morning.
How are you? Right. So as usual, let me take attendance. So starting from Anne. Yep. Innocent is absent. Samuel Tinega. Yep. Lawrence. Francis. Yep. Paul. I can't see Paul. Here. Lyle, he sent a project, or he's going to delay. Jones, he sent me a message. Luke, Sapa, Edwin, he's on way. Yeah. Beth, yeah. June, yes. Faith, she sent me an apology. Shabak, Bruce, Edmund, okay. Thank you very much. Yep. Oh, Corey, yeah. Thanks for your point. Okay. Yeah, so I have shared the minutes from today here. So let me follow this agenda. So first of all, I have a couple of announcements. So I tried to update the teams in our project website. So send me your profile photo so that I can upload. Yeah, right. Send me a good photo, right? Yeah. And so now the teams are purchasing items, and I'm going to refund if you pay. So once you upload your receipt, it will be automatically uploaded on this Excel sheet. And if when you upload your receipt, yeah, it can be seen from this Excel sheet. Yeah. So this is just a reminder. So once you make a payment, you must upload through this Google form. Nakuja, let's see. Yeah, this one, right? And some Liquid Things is currently purchasing something from Pixel and Nerocast. That's why live is late. So, and you can still ask me to make a payment to M-Pesa, yeah, if you request. So don't hesitate. Because I have seen, I was checking the last week's schedule, I mean the tasks, and I was seeing some teams are requesting to purchase items, but they didn't. So I want to encourage the, the purchase of the items as soon as possible. Okay, that's it. And so let's move on to the next agenda, which is a progress report as usual. So this week, can I request the solid propulsion teams to make a presentation? GitHub or Discord? Sorry. Oh, just okay. Before starting, I want to check something on last week's minute. So you promised that you're going to work on design of the three types of the test stand, downward nozzle facing, upward nozzle facing, sideways nozzle facing, pickup test stand design. So let's see if it's covered. Yeah. But anyway, yeah, please go ahead.
Okay. So this week we have finished designing on the first week. So we have plans to fabricate and that's the first step is the management model. Specific management model takes around 1 day to finish up the so we decided that instead of 6 we need to go back to this instead of the time it take 4 days to make one part at the same time. So the design involved using the basic sideways and rod, and so usually you need to press on it with compressive force so that you can push out all the air. But that really that will not be if there is distributed and there is no need to give it to the application amount of force. So we decided to go with this kind of design with the rod just created and this plate we also created this that you can just force the compressing and push it downwards. And then you are able to tell how much force you push by the member chance. So that you put it in any amount of times you want. So that is the design for it.
Oh, okay. So what is the material?
Or the material of the base is going to be wood and then this metal sheet of the top so that you can use flat. And then the material of the tube is going to be
Here.
Oh,
okay.
Yes. And the rod is going to be metal sheet and threaded. And the plate is also going to be metallic.
I see. So once you cast it, you're going to extract or remove the grain, right?
Yes. Also, the tube is not been placed on the plate panel. It's been there's a group that's been exactly a group placed. So you just slide it towards and then you compress to make the mold and then you remove it.
Okay. Okay, fantastic. Maybe one of the concern is, can you remove it? It might be sticky to the wool. Do you have any mechanism to remove it? I mean, of course, yes.
What's the street is not exactly the dimension. So that you make a much dimension about the space. So that you can be able to make our own dimension.
I see. Yeah, because you compact, right? You compress. So yeah, I'm wondering. Okay, just an idea. Maybe you can look at it, what others are doing. But if this mold can be separated like this, it is easy to remove. So maybe, yeah. Yes, but I'm not sure. Maybe you can try it once. Then you will see how it's feasible. Okay, please go ahead.
Side. The next one is the propellant. The lights with the airframe and the fan lasers to come the final design of the propellant start to be K plus 51,107. The drum, the motion is and the Pascals, the fits within the operations of the case.
Right?
So these are the final values. I want to approximately
Okay. Finance 4 grams. Okay. Initially, you are proposing 6 grains.
Initially, it's 5 grains.
5 grains.
It's just growing. Just that we used it.
Okay. Right.
This is how the entire of the the model, then we data and we keep all the full this. And that is the ground, the and the back, and the top, the schools. Connected, there are 6 schools.
6 schools. Oh, okay.
There are 12 in 6 schools.
Oh, so here, this is a school. Or, okay. This side, also school. Okay.
And we will change all of the
Right.
So I promise to come in particular this time when this is the first time. Someone who is in
So the materials will be okay on the line.
Yes.
Oh, the motor is such long. This is a motor. I'm wondering how to plug it. How you are.
Or it's going to be on the schools. They already mentioned this. So, and the other side, the estimates school issue is the coordinator package. That's good.
So this is one single screw.
Yeah.
There are 2 screws, this side and this side. Are you going to create a hole for?
The schools are the cheap of them.
Okay.
They're not all of them in the same direction. Side with the sun from where it started. So, yeah, we can check the reports.
Okay, I'm wondering, is it can it sustain, because the thrust will be generated in this direction. So basically, it's going to be going down.
Yes.
So where is the mechanism to support? It seems it's free. It's going to go down.
The bottom will
Oh, so you have something here.
Yes.
Okay. Maybe it's better to include. Yeah, such a structure.
Gauge.
Yes.
These ones which they use and for one. So even the one
I see.
the previous one had was simulations. Where nothing that was problem solving so
And how much is the weight? How many kgs? Yeah, because weight is very important, because if it's too heavy to carry, it's not feasible. You have to think about, yeah, it should be light, but if it's too light, it will be affected by the thrust. So we have to think about how to fix the test time. So yeah, you need to consider such balance. Okay. Oh, and you were saying that you're going to protect, or you're going to attach a kind of a cover, like a transparent cover, the polycarbonate. Yes. So the plan is still on, right? Yes. So I think I recommend you to add the protective cover here on the 3D CAD to visualize. And don't you have any cover here on the top? Yeah. So we have to eject the gas, but what will happen if this nozzle will be ejected? Yeah, it's like a projectile. It's like a bullet. Yeah. So yeah, we must. Yeah. Or kind of a metal net. Yeah, to protect this one from flying away. Yes.
So that's everything that we're supposed to design. So just materials, also fleet and is not available places to possibly start that.
Yeah. And another note for the weight, if it's too heavy, you might think about dismantling, like two parts. Then one person carry one, another person carry one, then assembly on site. Or another way is to add the caster here, like a car to carry. But yeah, maybe you can think about which one is the best way. Is that all? Oh, okay. Thank you very much. Yeah, I think I have asked you questions, sufficient questions. Do you have anybody has any questions to Solid team? I want to encourage this interaction. Maybe airframe team might have some issues regarding the motor. Or... Pardon the question?
No,
you don't have a question. Oh, you are discussing. That's great. Okay. So how is progress about procurement purchase?
So we have found a supplier for this materials, aluminium, so that on the website, so we need to do the process. So the solid component, the molecular coherence, the sealing. So when it's finished with those, or send them to separate. For the base, you just made it. We have as credits in this base, so we have to option to pass like this. It's possible
Okay, so kindly make a list of the items. Did you create such a list?
Yes.
Okay. Are there somewhere on the web? Yeah, you can share it on Discord, maybe on the Google Sheets. Yes. Right. Any questions? Oh. Okay. Thank you very much. Next, can I request the liquid team to proceed? So this. Yes. Let's look at propulsion. Before. Okay, just before proceeding, let me find out what is discussed. So you're supposed to work on acquiring parts. But let's see. Please go ahead.
Good morning, everyone.
Morning.
So for last week, we were working on the primary parts. So after going to the process, and after taking the, okay, so let me start from the beginning. We were designing a space for the nozzle. We had to fabricate some of the key components first needed before we assembled the system. So after heading over to see if it's possible to change it together, it's still some parts in there. Look at and say modify to compensate for the cooling which was so we decided as a lesson we needed to change the design. So in the report, we changed we instructed according to the key components which need to be modified for the project to continue. For the buffering, we started the hardware system, the hardware of the engine and the supporting structures which say included the space up. And now we have to go, we even discovered how to design hydraulic system for the tanks, the accumulators. So how we've been able to define the problem we've done aviation. But we actually put it on drawing and preparing the plan design for the structure itself and the parts required for the parts. We needed to check out the fitting and introduce the combustion chamber that we were assembling from. The walls don't have the requirement to hold the whole body together. So you have to look for the correct fittings for the walls. But as for the boardings, the boards are quite that much and stays perfectly with a bit of force. It fits without the modifying the transam also to be able to hold our accumulator. I will say that on to the next slide is the electronic subsystem. For this one, last week we were able to test accuracy of line, the heating power range, the temperature, because we plan to use it as a proxy for the combustion during the water test. You can see how the cooling system works, how efficient it is. We also tested the hydraulic actuation of the sensors, which are deployed to the one action currently here about below the one and in the square limits. The one and required low, but we still need to do some of them. We also were able to discover the power requirements in the supply to the test stand in order to give the components and subsystems, such as the test stand itself, the powering of the pumps, everything is on fire, and also to modify the test stand so that we can place the components themselves in a way which you can mark. Let's say if something happens, you can know exactly which of the systems for the project is going to on to the next slide. And finally, we look at the software control. So we determined for discussion the best method to use in this setting is PAE for we were able to also test them and check whether they're functional. Testing the power as well. And also, now we want to modify we also do the modification of the test stand to be able to go there and we want to make it such that it will be easier to see the different levels of control for the test stand. We basically troubleshooting the that's what we do.
Oh, okay, thank you very much. First of all, I request slides must include some photos, videos, graphs, so that we can understand, we can have a full understanding. Because when you say that boards, nuts, we don't know what kind of size, what kind of, where these boards and nuts installed. So visualization is a key for the information sharing. So that is one. And so this is a meeting to share a kind of a progress. So we need to have some kind of deliverables, right? So it is okay because sometimes in a week you are discussing. So you don't have much to show, like the schematics, like 3D CAD, PCB design. It is okay. But you have maybe for that case, you might have come up with specification. So you can create a list of the, in a form of table so that you can summarize the specification, various parameters, okay, so that we can see your progress. Because maybe, honestly, maybe if you show only these 4 key elements, we cannot judge if your work is progressing well or not. So maybe for that purpose, I want to see a kind of Gantt chart. So I think I have been sharing Gantt chart somewhere.
It's in the repository.
Repository, yes. Thank you. So yeah. Yeah. So now I think you updated this one, right?
Yeah.
So currently we are around here, like February 13th. So you should be okay working on publication of some components. Yes, I know you got a quotation from an MC, so that's okay. Okay, so we have, okay, I think you need to categorize this one because there is only one layer, right? So I think you need to categorize. Let me open the task sheet. I think you are summarizing, yes. So mainly you have 4 items. Then I think, yeah, you need to capture this one, right? So that, and maybe the testing. Oh, there are some more, okay?
If I mean, on the functional carbon design,
Yes.
we haven't like modeled the assessment yet because we actually have enough to do this. We have to like modeling from scratch because we didn't have canvas. And also like for modeling now is modified, we can also hold the chance themselves and also all of this control and electronic system.
Okay, I understand. I'm not requesting, yeah, you need to always show the 3D model or something, but I'm saying in this meeting, the purpose is to share the progress, right? So we have a deadline and you have a goal objective. So how much percentage you're completing will be our interest. So honestly, like from this presentation, I didn't understand quite well where you are, like how far you have gone, and like is it the 30%, 40%? So to explain it well, I think you have to always capture your entire task, like 1, 2, 3, 4, and you can explain like we are working on number one this week. And maybe in the following week, you can say that we completed number 1 and currently we are working on number 2, something like that. And this is detailed, okay? So presentation must be comprised of 3 components. Let me show you. So presentation slide, the number 1 is an overview, right? So what you need to do, okay? It's an objective. Oh, at the end, right? And number two, it's summary. What you have done. Right? So summary is something like which software or in the last week or previous week. Number three is the detail. Right? So like photos, 3D CAD, PCB design. So now you're talking about only the details. So these three, for me, it sounds it's a detail. Okay. So there are two components missing, which is overview and a summary. Right? So maybe in the next presentation, you can think about improving such an aspect. Yes, and I was not able to follow the issue of manpower. So because some kind of request is coming to me to be involved in the team as an intern. So I think I'm going to catch them, then input and insert them to your team propulsion. And another note. So I have been visiting IPIC to interact with you. Okay, this is not just for the executive, for the entire team. Maybe I'm not seeing some members. Then I understand maybe some people are going somewhere to purchase for the experiment. Yeah, it's okay. But maybe I need to clarify that if you are absent, if you are not coming to IPIC, please inform the team lead so that the team leader should always aware, where the members are. So, and the first promise is that you're going to stay here from 9 to 5, right? And you can, actually, it depends on your activity. So it's not an enforcement, but you have to always inform your team leader where you are, what you are going to do. So just a heads up. All right. And leakage team. Paul, and do you have any concerns, or maybe we have discussed yesterday, but apart from that, do you have any other?
Even some of the practical work was there is another coming up with objectives to travel.
Okay.
Yeah. So now I'm getting information. With the other,
Right. Okay, let's continue the discussion. Yeah, I will assist. Okay, any questions to Wiki propulsion team? Any suggestions? Questions? Okay, so yeah, thank you very much. And don't forget to add items on the minutes. So for the solid propulsion team, your work has not been ended yet. So I mentioned this, for example, you have to capture what has been discussed, right? So for the molding stand or something, I don't know how to call it. It should care about the removal of the rain from the wall, right? So this is what we have discussed. Then for test stand, you have to carry so the weight. How many edges and caster for this assembly functions. Okay, so this assembly. Consider some assembly and how much was the other side. It's a polycarbonate in the top should be MetaNet something. So yeah, we have to capture that. Maybe here and maybe on the Discord so that you can remember what we are going to do. Yes. So this is for the purpose of keeping the record. Maybe, but for information sharing, maybe it's better to share the information, the same information, the Discord as well. Liquid propulsion, yeah. So you're going to work test time modification, first component system, type design, both and material chips. Yeah. We yeah, I think that's okay. Okay, so thank you very much. Let's move on to the next group. Can I request the airframe to proceed? So you have uploaded. Okay, let me open it. Okay. 2, 3, 4, 5. So 4. Oh, it's fine. Yeah. Okay, before going to the details, this week you are supposed to work on the 3D printing nose cone, revision of parameters, finalize roach part design, generation of bill of materials, and procurement of materials. Okay, please go ahead. Money.
Already started to be thinking and running the parameter and I like parameter the design also as I would say, started the thinking we decided to go first institute the design. There was a challenge to printing in front of the day, so we decided to after finishing the remaining days, we thinking we hired the team to see whether they are going to be and also some of the parameters like the comparative load, but marketing load and the coefficients and also realizing that we get to be optimal value for the designs. So by the end of this week, we have come up with the parameter.
Okay, just a comment. Maybe to clarify, I think it's better for you to list what kind of parameters you are revising. Yeah, you mentioned it's a drug coefficient.
Yes.
Yeah, so you can list which parameters. Just advice.
Actually, the optimization basically for the emergency data and also that relation with the one that's the thing get the normal forces begin. And so by different configurations of the beam and say bring out the root and for length the data can be by the record. Yes. The simulator says Yeah, just to make it. Yeah, probably you mentioned maybe they are very list, and then we should know what are the values, those values in the budget.
Well, this kind of values because we were asking the budget team when the best model to use. So since you're already finalized on the model design, you cannot finish it off because the only problem we have is the model design is possible to about it. Now we're following the investment now. We're going to go back and then that's down to finalize.
Yeah, and maybe an additional comment is so you are using OpenRocket to optimize. So for optimization, you might have a strategy, right? What is optimization? Usually, you are minimizing something, some parameters, or maximizing some parameters. So changing such a there is some independent parameters and varying the parameters, you are maybe maximizing some objective function, something. So maybe you can mention that. So by sharing such information, we can discuss because you're saying that we are optimizing, but there is a possibility you are not optimizing. So that, yeah, by sharing such a detailed information, we can discuss. Yeah.
On the launch pad, we will design the launch pad since the previous one, the first design. The build was not stable, had a lot of wind, pressure settled on a solid build, and also the blast deflector. We designed for the surface to be carved in a smooth and well designed so that it can easily dissipate the engine process in a proper manner. I think in the following slide, there will be a design for the launch pad. One thing that we have also considered is the material of the glass reflector. From the study propulsion, we said that the engine goes to the future from the shell. So the stainless steel, the positive can start out with the so we are thinking to apply some structural materials in the surface of the glass reflector. Something like ceramic based constant hands. And also there's an issue. I think the rocket will be suspended some kind of level. That's the notable contact. There's some clearance or some distance between the notable and the blast reflector. So we're also thinking on how we can hold the rocket on that level so that there's some distance so that for the engine goes to low and be dissipated by the blast reflector.
Just wondering, so this is a stainless steel. This would be.
Yeah.
It is a kind of sheet because I'm curious about the shape. This is a metal stainless sheet, and you shape it like a conical shape.
Oh, and also the launch pad will be stainless steel.
Yes, yes, and also it's how do you call it? It's thin. It's lean. So I'm wondering the working. Did you estimate how much will be the deflection by the wind or by the vibration during the launch?
Yeah, that's also one of the parameters I think because we were thinking of using a very considering the thickness of the body, the rocket, which is not be feasible to maybe drill a metal groove. So And also it is the standard procedure for the non-short diameter to be at least 1/5 of the diameter of the balloon. So that is one challenge that we have. But we are also thinking of how to make the non-short stable, with less much.
Yes. Yeah. Well, yeah, you can just calculate the reflection, but just a simple, formula. It's strength of material basics, and also the here. So I want to see the other side. What is going on, or how to fix this load? Is it penetrating on the ground, or
Okay, the base is kind of a hole with thread, and also the bottom of the non-short is also threaded.
Okay.
So it will be kind of screwed into.
Oh, okay. I got it. So this is a base made of metal. How much weight?
Around 5 kg.
5 kg only. This one. How much is the diameter here to here?
The diameter of the glass meter.
Yeah.
That will be.
So maybe you can tell me the how much centimeter here to here, here to here. The square. Oh, sure.
The diameter of the glass meter is
60 mm. 260. Okay. Like almost 30 centimeter. So this one should be, let's say, 40 or 50 centimeter. And thickness. 30 millimeter, right? Yeah.
I think we should include the dimension.
Yes.
So that we don't ask so many questions and see the dimensions.
Yeah. So you can just add the dimension on 3D CAD so that it's apparent. But you see, saying maybe I can type here on the airframe for base rate. You're saying like it's a 50 centimeter times 50 centimeter times 3 centimeter, right? So it will be 50, 53. So 700, right? And how is yeah? Okay, let's say you are using a microscope. Density. It's 7.8. It's a gram. Okay, 7.87. So it will be how much? Kg. So gram. So divided by 10, 59 kg. Sure. I think, okay. So for me, it seems very heavy. And I think it's not feasible to carry it to the wrong side. Maybe you need to think about a revision or, and you are going to wear it here and here. Yeah, so it is not separatable, right? So not only 60 kg, this will be much more because you are welding. I think I recommend you to benchmark. Like you can compare the launch part of the other rocket team, right? Are there any teams who are doing this?
Not
Uh-huh.
even the previous rocket in Cuba,
Hmm.
I would not gotten someone information on the one they use
Mhm.
for the remnant of the launch pad.
Yeah, so I think you need maybe or definitely you need to have a literature review, right? Like benchmarking and compare with your design. And I think yeah. So basically, some literature review is still missing. So I recommend you to review the others more.
Main challenge is most of the literature
Mm.
on on the rockets, which can very much.
Mhm.
And if there are the rockets, then it's still important for us for this application.
Uh-huh.
So we sort of fundamental, which is
Uh-huh. Um, what they normally do is they are using, maybe it's better to see. Yeah. So why don't you have such a simple shape?
this design is something similar.
Uh-huh.
But then we're trying that we have challenges in the symmetric class. It will be so stable when you are listening to class.
And also
Symmetric class.
this kind of launch pad if you can and instead of the launch pad, using the
Uh-huh. You want to use rail rod. There are others like, okay, so this is rail. This is rod or rail. This is rail. Maybe can I ask why do you want to use rod?
As I said, the thickness of the body, the rocket's body, the small to form a group, so that's the rate and then the initial type.
Are there any workaround? Because it seems this rocket is not so different from our design. I'm wondering why they don't have such an issue.
Sorry?
I'm wondering why they are not facing such an issue.
Okay, in such rockets, they don't have the components like the unique, the things that are featured inside. So there's kind of some thickness to the body. So there's not much of blood inside. So then, and in our case, we need because of the weight of the component, we need the thickness to be more than possible.
Okay.
Reduce the weight.
I said the one anything as well.
They also use the launch pad, but the launch pad. Okay, from the video of the launch, it's quite some distance, so you cannot see the actual design of the launch pad. And also considering that our rocket is kind of bigger, there's that challenge about ensuring that the non-shore will be stable enough to get the rocket in trajectory.
Okay, I'm still wondering because for N2 we have been using rail. Yeah, so I wonder, and I suppose it is not impossible to use rail. There is a possibility of using rail for N3. So I think, yeah, let's discuss it later. All right. Oh, you have still. Go ahead.
Okay, we're trying to sort on the initiatives for communication. Basically, example, there's this for the aluminum tube. In this company, they not manufacture the aluminum tube for the standard size of 80 millimeter, which is we'll be using in our case. And if we will custom the aluminum tube, we say it's so expensive. So we settled on using aluminum sheet and folding it to the appropriate diameter and rotating to form the tube. That's some of the location of the company is in the next slide. This company
Excuse me, this is a sheet.
yeah, for your unit. The size is in feet, 8x4. The canvas they do not deliver, so maybe I done to deliver. I can't remember the not have a quotation, so we probably have to relate to companies that inquire about the price.
For this one, you don't have 3 quotation. We can go ahead with this. I think Ken's Metal will be also Ken's Metal. Do they have such a aluminum sheet? You're not sure.
They do, but
They are not responding.
you have to go to the company what they have to have their present.
Oh,
Petitions online.
okay. So personally, or maybe just to inform you, the Ken's Metal has a kind of unique practice for in terms of payment. They issue the invoice after our payment, and this contradicts with our JICA's accounting. So I prefer not to use Ken's Metal if possible. So just go ahead, it's approved.
So what we'll be focusing on is analyzing the communication of communities and discussing figures and also the implementation of literature for the parameter.
Okay. Right.
Next week we expect to do application of the airplane using a regular Paul was in the previous project, so I think it will be helpful in the regular work involved. The revision of the parameters also for the duty alignment, for the FINA alignment, we are expecting to design it and also a lot of it's not a complex meaning. So you can also begin from the beginning. But I don't think Basically, you cannot do it, so don't think there's a problem.
Probably one item you might consider is development of the jig for the aluminum fabrication. So I rocketry aluminum airframe. He was saying, oh, I might share it on Discord.
I think you did share.
Yeah, I didn't.
You did.
I did. Yeah. So to create such a airframe by aluminum sheet, he was making such a jig, right? So you're going to develop a similar jig. Maybe you have to. Yes. So you need to consider like when you're going to develop, or maybe you can, because let's see, on your airframe project, where is airframe? Next, we go to here and projects and airframe. Yeah. Let me check, because you have to design of pin alignment jig. Design of, okay, pin alignment jig exists, but that doesn't exist, right? Design of aluminum airframe jig, something. And then sheet airframe jig. Yeah. So you have to, yes, create such a task, right? And even in the task sheet, not to forget, you have to yeah. So airframe team might design fabrication of airframe. Yeah, fabrication of some components. Maybe you need to consider the design fabrication of sheet airframe. Origin. Yeah. You can also describe it here. So discuss who is going to deal with it. Much. Maybe then we consider using rate instead of plot. This yeah. Oh, this is third week. So fourth week, airplane. Yeah. Okay. Okay, so now it's over. Do you have any comments? Yeah, maybe for Tamshiri, we were discussing the improvement. First of all, it looks heavy, and we estimated it's almost 60 kg. It's welded, so it will be very heavy. And I was wondering, and a different perspective is they are using a rope, but it might be better to use rail as Nakuja 2 rocket. And if we go, if we look for some images for the model rocket, there are many simple launch pads like this. So, and they are using a lathe Yes. So, yeah, we discussed and we decided to reconsider not to use road, and we are going to use rail.
The last thing, fast or IC. The volatile. And material that we use in the fundamental.
Yeah. Okay, any comments, questions?
There is no best parameters. Then the optimization. You have to say, it's either minimum or parameter. And there has to be a function, there's the element function, for the objective function. So that one, I think is the only way we can get optimization. Otherwise, these others are manual investigation. Yeah.
Thank you very much. Some comments?
I was wondering if you could come up with a consistency question. Then there's a library material called Benot. It's used for dynamic optimization. Can you call the chambers to give you an optimized version which you can work back to?
I think you can inform them more detail, yeah, by discussing with them. And so if you want to control the OpenRocket from MATLAB or Python, it is possible. There is a OpenRocket Java interface. I think it can be, okay, Python can be used, I guess. Yes, so there is a library by which you can control the OpenRocket from Python. So maybe you can consider. And I think Rodney was using such functions, if I remember correctly. So you can also consult Rodney. Okay, yeah, just information. So thank you. Airplane team is. Yes.
I was in Windows site control team. So we were asking people from the reaction from the one report the shallow thing triggers a different signal which is in the critical reaction zone. It is not spin as much and then translation is still the persistent steroids. So I saw something occurring in the play control system. So I was asking if they was not reaction
For M3. My decision is not to use any flight control system for M3. The reason behind is that we are going to focus on the recovery system for this M3. We are going to hire apogee and we successfully recover this rocket. So that will be a primary mission. But we are still interested in a flight control system. So you can also talk to Felix Sami, who has been involved in flight control in N2. That maybe you can suggest for the way forward. But for N3, our primary target is recovery higher apogee.
Maybe also just to answer the question. Decided to have constant all around. So I think we don't design sure that will be solution in this section.
Thank you. Good. So final team will be airplane. So I think you have uploaded something. Yeah, so before going into the details, so in this week you were supposed to work on rocket tracking using GPS, manual override system design, Wi-Fi range test, wraparound touch antenna research and design. Okay, please go ahead. Just a moment. Yeah.
So, we have, for the something, we are able to collect the data and the my colleague said that I need outside Mambo Park and we have work to do because in Mambo Park, the GPS module was taking away the community and the GPS. So we need to actually try to keep for updating for but most of the issues solved the only will have a with the battery that we were using on the provided in our academy, but then after we shifted the line of battery, that is solved and we are able to make the data. Now the very big to the dashboard. Also, we had started activities on how to for the different. So this thing we had started writing the law on the other issue is the of the homework. We are able to take over the system and for the assembly document. So we have to take them so far, but then and they will provide your overall information. We have to be the example we have as we have a relation with the when they actually change the data.
Just maybe I have a question about this. Can I please? So you're going to push forward by the explosion. I see. Is it reusable? Like you fill the powder and fire it, and can you reuse it? Like refilling the powders and reuse it, or
In the next phase, the test.
is it a PVC?
Yes. Yes, PVC, whatever we put into it, and a lot of it is like one floor. But for now, we have
Did you calculate? Okay, still, again, the weight, that's a mass. You can calculate how much force or thrust should be added to the whole to eject.
We haven't calculated again, we just done the design. So this week, we'll get the diagram and we'll start it stepwise. So at 2 grams, we then want to test how much that's out of and we'll be ready. So we have yet to do that.
Again, it's heavy, so it will be waste of the thrust because our primary target is to eject the parachute, right? So the thrust here will be used to push the parachute in the nose hole. And because this mass is just a waste, because we have to accelerate this one by the thrust, generated by the exposure. So yes, I think yeah, I encourage you to calculate. Yes, the required amount of the gunpowder, because if the gunpowder is less, it means we can reduce the weight of this system, which is very good. Yeah. So yeah, you can still decide by experiment, but the simulation or the calibration is a key.
We have maybe a different thought about it. They may consider replacing boards. Can be some of the plastic shell.
Yeah.
And then on the inside, actually put the plates. So that this the children eat the things. Then the other part is basically plastic.
Oh,
So you eliminate that because that is the most critical. Yeah, that it doesn't burn through.
I see.
Yes, so they're not the plastic will come in contact with so much. Yeah, maybe that is sort of
Yeah, thank you. That's a very good solution. All right, so let's move on.
So we had static time of the local unit. So part to it, we will get the maximum we are able to achieve is to 50 meters. And I think this one has to be the targeted training that is working. We are looking at different ways to increase that. Until that we have this capable of looking 5 kilometers. So maybe we are in our offers, for example, the check the best we can it's something and also do it. So we are trying to put some more open ground and also the power of the that and also we are considering to do for it. The reminder of everything, but also extending the signal via right? So when I send the reminder why okay, like to place and the equal that there is you are able to give all the so that is like you know
Okay, I think you can deprioritize this one because you know it's dependent on this. Because if you cannot achieve 2-kilometer communication, the manual override doesn't. Yeah, you get it. So I think you can prioritize this one, and maybe once you set this issue, you can move away. Are there any possibility if you use touch antenna, can you extend the range, communication range?
Yes, we can. However, it's fast and since it's not expecting that we will alone with this and due to the Wi-Fi range. So we were able to again the antenna, the receiver antenna and the transmitter antenna. So we need to get the power and the gain of the transmitted antenna. It's 2 kilometers. So then that we are able to design the antenna, the patch antenna. So yes, we can do that, but we have to first set our standard at the restriction. What I need to we are done.
Right. Yeah. Thank you very much. I think I have asked you a couple of questions. Do you have any other questions?
I heard someone say, I heard you say something like I want to somebody testing in that room.
So I think that. For the grounds and
Yeah.
Yeah, no, actually, all I needed to know is, when it is actually wants to do that. That's really the, I was asked about it yesterday, since I don't think we need somebody. Let me know when it is to go to the testing.
Yeah. So I think for the test which we have done last year, we have asked help from the company, Joy company, and yeah, so we need to agree on the schedule or date. Now you have to think about how to prompt it. Last year it was they just improvised, so there is a rope here and here, and funny enough, we have to always cut the rope. And someone has to go how to say below the drone there, cut the water. So if you are going to test using drone, please come up with some mechanism for mounting avionics way to the drone. And another information, I have been asked that at that moment, they wanted to test the pyro technique using the drone, but it is not possible. Yeah, it is prohibited to carry the such gunpowder kind of weapon, something with the drone. And also, for the empty rocket, someone had to direct the antenna manually. So I asked you to come up with a stand. Maybe if it's automatically directed, it's much better, but it can be. It is okay, it's still okay if it's fixed, but you may know it, like in M2, our second rocket, which is Belkera, was really successful, but we couldn't track the apogee. The reason is the antenna was left on the ground, so everyone was busy, and there was no one who was directing the antenna to the rocket. It was very sad, so please come up with a stand. I'm sorry. Oh, this code. Okay.
But then it is more actually.
Oh. Yeah. Oh, oh. Hey. Okay. Yeah. Thank you. Well. Any other comments, questions? Oh, by the way, the Jibebe electrical vehicle project, the team was saying that they had an issue about getting the information using a GPS sensor. Did you have such an issue, the same issue?
It's not actually.
And how did you solve the issue? What was the solution? Oh, okay. Okay, great. Yeah, that's good. You solved the issue together. Okay, fine. Thank you very much for participating. I think that's all for this meeting. Any other business, final comments? Shiri, do you have something? No. Okay. Yeah. So thank you very much. Now we are almost in the middle of the internship. So I expect this internship is for 10 weeks. Okay. Minimum is 8 weeks, but I say this is for 10 weeks. So let's work hard to achieve our goal. Thank you very much.